So let's do another expected value. There's an equally likely chance that your dart will hit anywhere in this drawn board. You get 40 points for hitting the white area, you get 20 points for hitting the light gray, and you get 0 points for hitting the dark gray. What is the expected value? This is what you're looking at. Points per dart. So this is what your X is. It's the number of points. So let's just make our little table here. I have to make a table. So we get 40 Let me go back and look. We get 0 points, sorry. We get 20 points, or we get 40 points. Okay, so that happens. So the 0 points is for the dark gray. The 20 points is for the light gray. And the that is 40 points for the white. All right. My table may get a little bit big here, but that's okay. So my probability, P of X, dark gray, I've got 4 of those. On the light, actually that's incorrect. 1, 2, 3, 4, 5. I've got 5 of those. I've got 1, 2, 3, 4 of the light. And I've got 1, 2, 3, 4, 5, 6 of the white. So that's going to tell me I have 5 of 15 rectangles. 1, 2, 3, 1, 2, 3, 4, 5. So I have 15 total rectangles. And here I have 4 out of 15. Here I have 6 out of 15. So my decimal is going to look something like this. Okay, so my new expected value here, I've got the expected value of the points per dart. Okay, so I've got 0 points times 0.33. I've got 20 points. That is not a decimal. I have 20 points with a probability of 0.27, and then I have 40 points for a possible 0.4 outcome. Let me get that off there. Okay, so then what we want to do is run the numbers. That's going to give you 21.3, and then we're looking for points per dart. This is points per dart. Okay, so on average, in the long run, all these things have to be in there. A person should expect to earn 21.4 points per dart thrown. Okay, so that is number 3. Let's go ahead and look at number 4. So we're going to roll some dice. Okay. So a dice game involves rolling 2 dice, and here are all the outcomes for all the 2. If you roll a total that is a 2, 3, 4, 10, 11, 12, you'll win $9. If you roll a 5, 6, 7, 8, or 9, you will lose $6. Find the expected value you win or lose per game. So if you're going to win or lose, what we're talking about is money, so we're going to look for dollars. As far as that winning idea. So let me make my little table here. So the X I'm looking for is dollars. Sorry, I keep moving my paper. So we're going to either win $9 or we're going to lose 6. So if you count, it's nice to have the picture here. The total number of rolls, there's only one way to get a 2. There are 2 ways to get a 3. So if you count all those up, all these outcomes, looking at the picture, there are 12 ways to earn $9, and there are 36 outcomes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there are 36 total outcomes. Okay, so again, what I did was I counted the number of ways to get a 2, the number of ways to get a 3, a 4, a 10, 11, and a 12. If I get those, there are 12 ways these can happen. So now I'm going to count up the ways to roll a 5, a 6, a 7, an 8, and a 9. And you just look here and just do a tally and count them. Okay, there are 24 ways for that to happen out of 36 possibilities, which that is your P of X. So in decimal form, I mean, I like to think of this as a third and 2/3. So the thing that's going to make this a little bit different is if you use a fraction, you're going to have to do some rounding because those things have repeating decimals. So if you want to be more precise in your expected value, then you could definitely use the fraction, put that in your calculator, and then round at the end, which is what I would recommend. So my expected value, I want to know, I expect how much to lose, how much to win or lose. Okay, so my probability is 1/3 of a chance to win $9. Now, if I'm going to lose 6, then, lose 6, I have 2/3 of a chance to lose $6. Okay, which ultimately that is the same thing as subtraction. Of course, you know that. Well, that's going to be a 3. This is going to simplify to 2, and that's going to be -4. You don't even have to run a calculator on this if you keep it in decimal form. So actually, that is a -1. So this is what my probability is right here. So that means I expect to lose $1 every turn. Okay, so in the long run, I expect, or one would expect, to lose, on average, $1. The lose means the negative. Lose $1 per game. So that is your expected value for the dice. Let's go ahead and get this one out of the way. I've got life insurance policies will pay a beneficiary a certain amount of money if the holder dies. Suppose a company sells $250,000 policies, so this is the amount of the policy, we call that the face value, for 1 year life insurance to a 49-year-old woman for $530. In other words, whoever takes that policy out is going to lay down $530, and they're going to get this face value of policy, and this is for 1 year. Okay, compute the expected value of this policy to the company if the average 49-year-old woman has 0.99791 probability of surviving and not gaining from the policy. Okay, so the one thing you have to think about, this is the probability if she lives. Okay, so the probability that she survives the year, I'm going to do a little prep work here, is 0.99791. Well, there's also a probability to consider. The probability that she dies first year. They didn't give us that probability, but since probabilities, when you add them up, if you have a string of them, they all must add to 1. So you'll notice up here, if I add these two together, they will add to 1. So basically, all you have to do is subtract from 1, and you can get the unknown probability that you're looking for, and that one is 0.00209. Okay? So what we're looking for is compute the expected value of the policy to the company if the average 49-year-olds. In other words, we're looking at income for the company. So if I make my little table here, so this is my income if she lives. Okay, let's see how I want to do this. Let's do this. This is lives. This is dies. Okay, so if she lives, the company is going to earn that $530. If she dies, then what's going to happen is they're going to have to pay out, this is within that year, minus the $530. And yep, that's how that's going to work. They can expect to lose $249,470. Okay, so if she lives, they'll pocket that money. If she dies, this is what they're going to pay out. Okay, so now the probability that that happens is if she lives, young, healthy woman, going to be here. If she dies, you've got this amount. Okay, so we want to calculate the probability of surviving the year, okay, or the expected value that they're going to get, okay. So the expected value of if she survives. So we've got the amount earned. Let's make that a little bit better. If she survives. So there's my $530 times the probability. Here is the amount that when she dies, that's a 4, 9, 4, 7. In fact, we want to refine that because they're fixing to lose that money. They're fixing to pay it out. So if you want to look back up here, you can refine it this way if you want to think about your signs, or you can be logical about it. I try to just be logical about the thing because that's the money that's coming out. Okay, so when we run those numbers, you're going to run this in your calculator. Oops, that's a 7D. Then you're going to get $750, or excuse me, $7.50. So this is what this means. Over the long run, the company will earn, on average, $7.50 per policy sold to this particular demographic. And people think $7.50 isn't much, but if you think about how many 49-year-old women there are in the United States, and if they sold a million policies, then they can expect, because of the probability of longevity, they can expect to earn $7.50 per policy. If you sell a million of those and everybody lives, then this is multiplied by a million, and you've got a chunk of change right there. So this is expected value.